Hello, my name is Luke Ripstra, G number G00118984. I'm a senior at Grantham University, pursuing my Bachelor's of Science in Computer Engineering Technology. In my free time, one of the things I like to do is roast coffee beans. While shopping for small batch coffee roasters one day, I noticed that only very expensive coffee roasters featured customizable roasting programs, and only one non-commercial coffee roaster that I could find actually interfaced with a computer. That's when I realized it would be nice to design a coffee roasting control system which features completely customizable roasting programs, cooling programs, as well as interfaces with a computer. And I figured I could do this all for a much lower price than is currently available on the market. So for my capstone project, I've decided to design a microcontroller-based coffee roasting control system. The design revolves around an Arduino Uno development board as the microcontroller circuit connected to a plethora of components. The first of which being a K-type thermocouple connected to an AD595 thermocouple amplifier IC. That is for sensing the temperature within the coffee roaster. Next are three electromechanical relays which will be used to turn the AC components of the coffee roaster on and off. Specifically, the electric burner elements, AC synchronous motor for agitating the coffee beans, and an AC fan for cooling and convection will be controlled by the relays. The relays are connected to the Arduino through the use of MOSFETs for amplifying the Arduino voltage as well as through some protection diodes. The system also features a small servo motor, which will be used to rotate a valve located within an air inlet vent in order to introduce cooler outside air into the roaster during the cooling cycle. The servo motor is connected in parallel to a 470 microfarad electrolytic capacitor to minimize excessive current draw from the microcontroller. A magnetic reed switch is also connected to the circuit, which controls a hardware interrupt routine on the Arduino. This was included to turn the AC elements of the coffee roaster off when the door to the coffee roaster is opened during operation in order to protect the end user from any moving parts or active burning elements. Finally, on a separate circuit board are 4 switches for manually controlling the coffee roaster, along with 6 indicator LEDs. The bulk of the work of the coffee roaster control system is performed by the program written to the Arduino MCU. The program features multiple functions, one for the initial roasting setup, one for preheating, manual roasting and cooling, and one for automatic roasting and one for automatic cooling. The program automatically keeps track of the timing of the roasting and cooling functions in both automatic and manual modes. The program then reports the elapsed roasting time and cooling times after the program is finished to the user. This allows the user complete flexibility when operating the coffee roaster. Finally, all the user prompts and program outputs are displayed using the serial communication and can be accessed by the Arduino IDE serial communicator. But as a proof of concept for demonstration purposes, I've developed a simple graphical user interface in the C# programming language using Windows Forms that will display not only the serially communicated messages from the control program, but also displays the temperature of the roaster in real time and allows for user input. The following demonstrations will be conducted utilizing that application. So let's take a look at how all these pieces come together to make what I call the Smart Coffee Roasting Control System, or SCRCS. For the first demonstration, we will operate the SCRCS in manual mode. During manual mode, the roasting function and cooling function are started and stopped by utilizing the respective buttons on the control panel circuit board. And notice that I have covered the control panel circuit board with a cover that features some labels just for demonstration purposes. To simulate the heat generated by AC burner elements, I will use a space heater directed at the tip of the thermocouple to raise the temperature of the air around the thermocouple. We'll begin by connecting the USB cable to a computer with the demonstration software installed. Then we'll open the SCRCS Demonstration program. And we'll make sure that it is connected to the Arduino. Alright, now we are receiving instructions from the program loaded into the Arduino microcontroller. And we will set a target temperature for 150 degrees. Alright, now we'll choose to use convection, meaning the fan relay should be on during the preheat, roasting, and cooling cycles. Next, we'll pick a manual roasting mode, as well as a manual cooling mode. Now everything's all set, and we'll go over to the physical circuit. And before we begin, I want to point out that I'll be verifying the relays are turned on by measuring the resistance across the switch contacts on the top of the relays using this multimeter here. A high resistance or infinite resistance measured by 1 means that it is open and there is no electricity flowing between the contacts. A low resistance means the relay switch will be closed and there will be electricity flowing between the contacts, activating the element. Okay, now we'll begin the roasting simulation. And I'll start by pressing the preheat button on the control panel. Now I'll measure the resistance across the relays to verify that the burner relay and fan relay is on while the agitator relay is off. So we'll start with the burner relay. Alright, that's showing a low resistance, meaning it is activated. And we'll do the fan relay. Okay, low resistance there, meaning it is activated. And then lastly, we'll do the agitator relay, which should be open. Excellent. While the circuit is preheating. Now we'll go ahead and turn on our space heater and heat up the tip of the thermocouple to simulate the roaster warming up. Okay, notice when I adjusted the thermocouple, the heat jumped up to 270 degrees. Excuse me, it's still rising. It'll probably hang out around there. But the ready light is illuminated on the control panel. And I heard a switch. We'll check and verify that the burner turned off, meaning the roaster believes it has reached temperature. Yep, we've got a high resistance there, but the fan should still be on. Absolutely, and the burner, or the agitator should be off, and they are. Excellent, in business. All right, now we'll start the roasting cycle by pressing the roast button on the control panel. Okay, and again, we'll take some measurements to verify the temperature. All right, so we'll start with the burner, and the temperature is reading above the target, so the burner should be off. The fan should be on, but now the agitator relay should be on. Excellent. And now we'll move the thermocouple out of the heat. And we'll recheck the relays. All right, the burner relay is now on since the heat target temperature is below, or since the thermocouple temperature is below the target temperature. The fan relay should still be on. Excellent. And the agitator relay should be on as well. Very good. Okay. Let's make sure that the door ajar switch actually turns all the relays off when it is opened. So I will move the magnet away from the switch here, simulating the door being open, and the burner should be off. Yep. The fan, correct, and the agitator. Excellent. I will close the door, and there, I just heard a click. We should have the burner. Excellent. Burner is back on. The fan, as well as the agitator. Okay. Now we are ready to start the cooling cycle. And I'll do that by pressing the cool button on the control panel. Notice the servo motor rotated 90 degrees to allow air to enter into the coffee roasting chamber, and the LED lights are lit. All right, and the program tells me that when my beans are nice and cool, to finish the process, I'll press the done button. We'll go ahead and do that now. Excellent. And here, looking at the communicator program, it appears we have a summary of this roasting profile here, that our target roasting temperature was 150 degrees Fahrenheit, roasting time 2 minutes and 2 seconds, and our cooling time of 0 minutes and 31 seconds. And lastly, the ready light is illuminated. Next, we'll demonstrate an automatic roasting cycle. I've pressed the reset button on the Arduino, and as well as closed the control application. I will go ahead and reopen it now. And I will establish a serial connection. Okay. And again, we'll use 150 degrees for our roasting temperature. And this time we won't use convection, so the fan relay should only be on during the cooling cycle, which we will verify. Okay. We'll also choose automatic roasting, and we will use a time, so automatic roasting, and a time of 2 minutes and 15 seconds. Okay, as well as automatic cooling with a time of 2 minutes and 0 seconds. Okay, now the instructions tell me to press the preheat button on my control panel, so I will do that now to begin preheating. Okay, notice the temperature is being registered on the control program. I'll verify that the burner is on. Burner on. And that the fan is on. Excuse me, the fan should be off because I chose no convection, as well as the agitator. Okay, those are both off. I will turn on my space heater to generate some good heat. Stick my thermocouple right next to it, and in no time, looks like the circuit registered is ready, or the temperature registered is ready. We'll go ahead and check, make sure the burner is off. So at this point, every relay should be off, since I'm not using convection and we're still in the preheating stage. Excellent. So now we will begin the roasting cycle. We'll press roast on the control panel to begin. And now it will time automatically and switch to the cooling cycle when the 2 minutes and 15 seconds is up. So while we're waiting, I'll verify that the burner should be off. The fan should be off since we are still above our target temperature, but our agitator relay should be on. Excellent, which it is on. And I will move the thermocouple to simulate the roasting cavity cooling down. All right, now it's below the target temperature, and I will go ahead and verify that the burner relay is on, which it is. The fan relay should still be off, which the fan relay is off, and the agitator relay should be on. Excellent. And again, if I choose to deactivate by opening the door, deactivate the relays, they should be off, which they are all off, and I will reactivate them again. Okay. And my agitator should be on. Fan should be off. And burner is on. Excellent. Okay. I'll just go ahead and move the thermocouple close again. I heard a click. Burner should be off. Yep, it is. Excellent. Okay. All right. We'll make sure. Yep. The burner is activated. Same thing with the agitator, should be activated. And it is. And the fan is off. Okay. So now we will wait for the cooling cycle to begin, which will begin automatically. Notice the auto light is illuminated on the control panel. Oh, here begins the cooling cycle. Notice the servo motor rotated open. And now we will verify that the burner is off. Burner is off. Okay, the fan is now on. And the agitator is on. Now let's check the interrupt. The door ajar during the cooling cycle. Okay, agitator is off, fan is off, burner's off. Excellent. And notice that as soon as I closed that door, or activated that read switch again. Here we go. Our fan is on, and our agitator is on. However, our burner remains off. Very good. So this will automatically now turn off as soon as the time is up, and we will see a report on the screen as far as our timings. going to make sure the relay is shut all the way. Looked like there was a small gap there. Alright, and our roasting cycle is complete. Okay, notice the ready light is illuminated on the control panel. And back on the control program, we see that our target roasting temperature was, the roasting time, as well as the cooling time elapsed. That concludes our demonstrations. Thank you for joining me as I demonstrated the Smart Coffee Roasting Control System, or SCRCS. Hopefully you can tell that it is a very flexible and robust coffee roasting control circuit that allows users complete control over their coffee roasting profiles. Thank you and have a good day.